Okay, guys, happy Monday. I hope you're doing all right. Today, we're going to start a new topic. We're still dealing with integrals, but we're going to deal with something called the mean value theorem for integrals. If you watch the videos that are posted, you'll notice there was also a mean value theorem for derivatives, which we've already learned. Today, we're doing the mean value theorem for integrals. They're closely related, but I almost want you to think of this as an independent idea. So, whereas the other two videos talk about how the ideas are connected, I almost want you to think of this as an independent concept, and I specifically want you to pay attention to this term here today called average value. So here's the concept of what we're doing. We've got an area under a curve, and we know the way that you find the area under a curve is by saying, in this case, it would be the integral from a to b of f of x dx. Okay, so that's how we would find that area in red. I want you to imagine for a second that maybe that area is a piece of ice. Okay, and that ice melts into water, and that water levels out. And let's say that we're still on the same interval between A and B. And let's say when that water melts, when that ice melts and levels out, that it refreezes. Okay, so that water would refreeze. That water would refreeze somehow. And so what we would have is we would have a rectangle where the area of the blue rectangle is the same as the area under the curve that we highlighted in red. Now, obviously, this is a kind of an interesting spot. There's something that happens here that's interesting to us. If we tried to maybe estimate too low, obviously in this case, the area of this rectangle would not be the same as all of the area under the curve. It would be a way underestimate. You can tell that because this underestimate is way bigger than that little bit of overestimate. And sometimes we can take it too far the other way where it goes up too high. And so basically the area of this black rectangle would be much bigger than the area under the curve that I've highlighted in red. And so the question is, where's the sweet spot? And if you look at the very first example I did, we would say the sweet spot is right there, okay, where that blue rectangle is exactly the same as the red area under the curve. Let's just call that new x value c, and so then the y value associated with that would be f of c. Okay, it would be f of c. And so now my question would be, for the blue rectangle, what's the area of a rectangle? Well, it's base times height. Well, what's the height of this? The height is the y value, which we've called f of c. And what's the width of this rectangle? Say this was 2 and this was 8. Well, the width would be 6, or if we're just using our variables, b minus a. So this formula for the mean value theorem for integrals that we see down here in this box, that is generated from us actually looking at some geometry where we say, I want the area of the blue rectangle to be exactly the same as the area under the curve. What's also interesting about this is that since the area under the curve represents an accumulation, if we were to divide both sides, to get that y value by itself, that y value, or f of c, would represent what we call the average value. So in other words, if I said to you, hey, what's the area under the curve represents the amount of snowfall. So let's say it snowed, 100 cubic inches. If I said, well, what was the average over the time interval? You would just do 100 cubic inches divided by however wide the time interval is. That's what average value is. So looking at what we have here, if I were to try to get f of c by itself, that would simply be 1 over, f of c would equal 1 over b minus a, right? Because I would divide both sides by b minus a times the integral from a to b of f of x dx. This f of c is called the average value. When we do that with real problems, that represents the average over a course of time. This formula then that is what it is. We just have a formula here that we have to fill out. The second half of the formula you already have done. You did this you've done it the last 2 weeks where you find the area under the curve. The only piece that's new is to find the average. We multiply by 1 over b minus a. Now listen, later on this week we're going to try to solve for c. Later on this week we're going to try to find what that x value is, and that'll be a big deal, and they kind of talk about that in the videos a little bit. But today's lesson is pretty easy to find the average value. We just follow that formula. So let's look at our first example here. Let's call that a, that's b. If I want to find the average value for this function, the average value is going to equal f of c, which is 1 over, in this case, 4 minus 1, times the integral from 1 to 4 of 2x cubed dx. So where do all these numbers come from? Well, we got 1 and 4. 4 goes there. This 1 goes there. The 4 also goes to there. And that 1 goes down there, right? So that's where those come from. This is simply the function, so 2x cubed goes there. And this is what we solve. So let's see, what is 1 over 4 minus 1? Well, that's just 1/3. And what's the integral from 1 to 4 of 2x cubed? Well, you could just put that in your calculator. Now, you could do this by hand, too, and you might have a professor next year that asks you to do that. But you could, for this lesson this year, just put this in your calculator, Math 9, and that would be 127.5. And so when you do 1/3 times 127.5, you get an answer of 42.5. 42.5 is the average value over that interval. So in other words, if I had the curve 2x cubed, that would be a really steep function like this from 1 to 4. The average value would be this y value, where we would have a rectangle that is approximately the same as the area under the curve. Okay, so let's just apply the formula to these new ones. Again, we're just finding the average value. We'll find what c is later. Right now, I just want to know what is f of c, or what is the average value. So the average value is f of c, which is 1 over, in this case, 9 minus 1, times the integral from 1 to 9. Make sure you get the order of those right. Don't flip-flop those numbers. Do it in the correct order, or else you'll get a negative version of the answer. And so this is going to equal, well, 9 minus 1 is 8, and the integral from 1 to 9 of 6 times the square root of x is going to equal 104. And so 104 times 1/8, or divided by 8, is going to equal 13. 13 is the average value of that function over that interval. Okay, so let's do one with negative exponent, or negative limits. All right, so this would be the average value is going to equal f of c, which is 1 over 2 minus negative 2 times the integral from negative 2 to 2 of x squared plus 4 dx. Well, 1 over 2 minus negative 2, that's like saying 1 over 2 plus 2, or 4. And if I put this other part in my calculator, the integral from negative 2, Math 9, the integral from negative 2 to 2 of x squared plus 4 dx, that equals 21 1/3, and 21 1/3 divided by 4, or times 1/4, is going to be 5 1/3. Guys, if we were in class, we'd be doing all of this by hand. We wouldn't be using Math 9 here. I'm letting you use your calculator to make this go a little bit easier. Be a little careful when you deal with trig functions. We'll look at this together. F of c is going to equal 1 over pi over 2 minus 0. Reason we got to be careful is we've got a fraction in our denominator there. The integral from 0 to pi over 2 of the sine of x dx. This will be 1 over pi over 2 times, when you Math 9 that, you're going to get 1. Well, I don't want to write my answers 1 divided by a fraction. When you divide by a fraction, that's like multiplying by a reciprocal. So the answer here will actually be 2 over pi, which if you put that in your calculator, you would get 0.6366. So 0.6366. All right, guys, do the homework. Tomorrow we're going to do a worksheet where we practice this. So tomorrow should be pretty easy. And then on Wednesday, we will try to go back and figure out, well, once you have the average value, once you have f of c, how do you find what c equals? How do you find that c value? That's what we'll do on Wednesday, and then we'll practice that on Thursday. So mean value theorem is this whole week. Should be pretty easy. Hope this helps. Contact me if you need any extra help. Have a great day.